Hello everyone, in today's optics video, I'll be talking about reflection and mirrors. The key principle of reflection is that when a light source's rays, in this case a flashlight, hits a mirror or reflective surface, it bounces off with the same angle it hit the mirror with originally. You can think of it like a pool table. When the cue stick hits the cue ball causing it to hit the wall, it bounces off with the same angle it hit the wall with. Let's take a look at what actually happens when light reflects off a surface. For demonstration purposes, we'll focus on one singular light ray coming out from our light source, the flashlight. Like we learned in the last video on refraction, which you should watch after this video if you haven't already, we learned about incident rays, the normal line, and the point of incidence. For those of you that haven't seen the video, the incident ray is the ray that comes from the light source towards the surface. The point of incidence is, as you might guess, the point where the incident ray first hits the surface. Lastly, the normal line is an imaginary line drawn perpendicular to the surface at the point of incidence and serves as a reference for various purposes. Going back to our diagram, after the incident ray hits the mirror, it reflects and moves away from the mirror. This is called the reflected ray. Notice that the incident ray and the reflected ray create angles with the normal line. The angle between the incident ray and the normal line is called the angle of incidence, denoted by the symbol theta I. On the other side, the angle that the reflected ray makes with the normal line is called the angle of reflection, denoted by the symbol theta R. The important concept here is the law of reflection, which states that theta I is equal to theta R. When light reflects off a surface, the angle of incidence is always equal to the angle of reflection. Now that we've learned about reflection, let's shift gears to learn about mirrors. The most common type of mirror we see in our daily lives is a plane mirror. These mirrors have a flat, reflective surface like the ones you see in your bathrooms. Let's take a look at this example where the dog is looking at himself in the mirror. For simplicity, we'll observe two light rays coming from above and below the dog. The rays bounce off the mirror and go into the dog's eyes. The dog sees a virtual image that would appear if the rays of light were to extend past the mirror. There is no dog behind the mirror. It only appears to the dog that there is. Now let's take a look at a curved mirror. There are two types of curved mirrors, one being a concave mirror. This type of mirror curves inwards. There's an imaginary point called the focal point, which is located at different spots depending on the curvature of the mirror. In a concave mirror, all light rays that hit the mirror reflect towards the focal point. We can see this present in flashlights, where light is directed in a coned area, or headlights on a car. Another example is the solar oven, which works by directing sunlight at the focal point, where a pot is placed so that concentrated rays of sunlight heat up the food. The second type of mirror is the convex mirror. Convex mirrors are the opposite of concave mirrors, in that they curve outwards. These mirrors also have a focal point, however it is behind the mirror. When rays of light hit the mirror, they bounce in a fashion that makes it look like they came from the focal point on the other side. This makes it useful for seeing large areas behind and around you. We can see convex mirrors in our daily lives like surveillance mirrors and in some rear view mirrors to help drivers and people see around corners and in wider areas. By the end of this video, I hope you can use your knowledge to answer these questions on screen. Reflection is a basic principle in optics that allows us to see everything around us based off the light that bounces off objects, so it's super relevant in our lives. Well, that's it for this video. If you enjoyed the video, make sure to like, comment, and subscribe for more optics related content.